Hey, Mr. Chu here. Let's talk about a couple of SAT problems. This is the last short video that has two problems on it in Module 1 of the SAT review problems, and I will put together a video that has all 27 on it that you'll be able to also watch if you want to sit there and watch them in one setting. So let's get to it because one of the problems is kind of long. So this is video 14. It's the 13th short one. Then there'll be one that has all of them together. The College Board released these review problems, and they're good review for the SAT, ACT, and ASVAB. Some problems will be easy for you, some will be hard, and they all require background knowledge in algebra, geometry, and other math classes like those that you have been taking leading up to this important test. So make sure you like this video if it's helpful to you for this important test. Make sure you follow me on TikTok, Instagram, Facebook, and X for math help videos. Subscribe to my YouTube channel. Here's the long link. You can also just click on the subscribe button. If you have any questions for me, I have an email address that you can send me a private email with questions, and I'll answer your emails. And then, if necessary, I'll make a video to help you answer it. I do have lots of math help videos in algebra, geometry, arithmetic, pre-algebra, and I'll answer any questions that you've got. All right, so now we're going to get down to the nitty-gritty. This is the long problem. If you see all of these dots everywhere, so these dots represent different lines that I have of trying to explain these in the best way that I can. So in number 26 here, it has a system of equations. And if you look closely at that first one, if I take and multiply everything on the left by a 5 and everything on the right by a 5, I get the same equation as the second one. What does that mean? It means it's another name for the same equation, and some might even call it what's called a simultaneous equation. It says for each real number r, which of the following points lies on the graph of each equation in the xy plane for the given system? So it gives you an x and a y coordinate in terms of r, and then sometimes there are fractions and numbers involved. So in A, you would substitute the x of r over 5 plus 7, the y of negative r over 5 plus 35, and when you substitute it in the equation, if the two sides are equal, and it's what's called an identity, it means that it's on that line. And then you could do it to the second one. Now, it just so happens that sometimes when you're working a problem, the easiest way to figure out, and it's a good test taking strategy, is to look at each of the four answers and rule out the ones that obviously are wrong and find the one that works. Well, we can't see an obvious wrong one. So we just have to start plugging them in. And then when you plug them in to the first equation, because it's the easiest one, and see if it's an identity equal on both sides, then you can plug it into the second one. What you're going to see is there's only one possibility that works for either of them. So we just have to go through that long algebra process of substituting each of those x, y values in terms of r. So let's go ahead and get started. So let's just start with D because I have to start somewhere and then I'll work backwards. So in D, the x is r, and I'm going to substitute an r in where there's an x. So I'll put an r right where this x is. And where this y is, I'm going to put this long rational expression multiply the r by 2, and then that long rational expression by 3, and say it equals 7, and substitute it. And if I get the same number on both sides, it means that it is on that equation. So it's just a matter now of just doing that now. So I substitute it in. I'm going to use the distributive property here to take the 3 times the negative 3r over 2, and then the 3 times the 7/2. And then I'm going to have to get a common denominator. So I'm going to multiply that 2r over 1 times 2 over 2, and then everything on the left-hand side of the equation will have a denominator of 2. And so I can combine the 2r times 2 is 4r, plus the negative 9r over 2 plus, and that's 21 over 2, and it equals 7. So the left has to equal 7. Well, it's pretty obvious that there's still an r over there. So since there's still an r over there, I combine my r's, and I'm going to multiply by 2, and I get negative 5r plus 21 equals 14. I subtract the 21 from both sides, negative 5r equals negative 7. So since r has a value, it means it's not an identity. Both sides aren't equal. That means that I can rule out choice D because D is not on that first equation. Doesn't matter if it's on the second one, but it's not going to be anyway because those two equations are equal. All right. Now I'm going to do it with C. The same exact thing, only now I'm entering a different value for Y. The X is the same, but I just substitute them in again. And then I take 2 times my R, and then 3 times 2R, which is 6R over 3. 3 times the 7 is 21 over 3, and then I can reduce 6R over 3 to 2R and 21 over 3 to 7. Oh, well, that makes it a little bit simpler, doesn't it? It sure does. So I've got my 2r plus my 2r, which is 4r, plus 7 equals 0. I subtract the 7 from both sides. And when I do, that's a typo there, I get 4r equals 0. And guess what? Since r equals a number and it doesn't say 0 equals 0, both sides are not equal, which means that I just ruled out C. All right. Now we go to B. I'm going to move this over for now so that it is not in the way. I'll move it up there. All right, so now we're taking and putting a long rational in for X and then R in for Y. So now this is going to look a little bit different now. So it's 2 times this rational plus 3 times R equals 7. So I'm going to multiply 2 times the negative 3R over 2 and 2 times 7/2, but the 2's are going to cancel so that we get negative 6r over 2, which will be 3r, and I could have just canceled those and got the negative 3r. Sorry, it's negative 3r. And then 14 over 2, which is 7, or the 2's could have canceled, and then I have the 7 there. All right. So negative 3r plus negative 3r is going to give me 7 equals 7. Well, guess what? 7 does equal 7. It is an identity, which means that it is on the first equation. Now, you can plug it in on your own to get it the second one, but I'm telling you, since they're equal, it will be equal. And then D is not going to work, and you can see all the steps here. And so, for A, so A does not work, B does. And that was kind of tough, but it was good to see that sometimes a good test-taking skill is just to plug in each of them. So choice B is the answer. So that was kind of a long one. Sometimes you can't just plug something in and work it. All right, now let's go to the last one in this first set of problems. It says the perimeter of an equilateral triangle is 624 centimeters. The height of this triangle is k squared of 3 centimeters, where k is a constant. What is the value of k? All right, first of all, we have to draw the equilateral triangle. And remember, an equilateral triangle means that all 3 sides are equal. All right? We know that each angle is going to be 60 degrees. So down here, this is 60 degrees. The reason that I know that is because not only is an equilateral having 3 equal sides, it also has 3 equal angles. And then 180 divided by 3 would be 60. Now, this is a 60-degree angle, the whole thing, which means that this one will be 30 and this one will be 30. We're given the height as being k square root of 3. So, since that's the height, we draw the altitude and we're given the perimeter. And an altitude is from this vertex down to the other one at a right angle. So now this is a right angle. So now this is a 90-degree angle. That's a 30, 60, 90 triangle. Well, a 30, 60, 90 triangle is called a special triangle. So I just underlined it over here. So we've got to review what it means when a triangle is a special triangle, okay? Because we know that it is a special triangle now. So what does that mean? Well, it means that I've got my 60, 60, 30, and then 30, and then this would be 90, this would be 90, so it's 2 special triangles. Well, we already know that the height is the square root, k squared of 3, but in the simple figure of the values on each of the special triangles, you'll always say that that height is x square root of 3, and these are just the sides. This side opposite the 30 will be a length of x, and the hypotenuse of the side opposite the 90 will be 2x. So if that's the case now, let's just think of what that really means. So that means that since this is k square root of 3, we can start thinking about how that altitude and this 30, 60, 90 will affect it. So these are all the givens. We know the measure of angle A, which is the big one, is 60. Each one of these is 30. And then we've got a 60 and a 90. But that also means that over here on this triangle, since this one will be x squared of 3 on our regular one, right? Then that means that the short one over here on the left triangle, this distance from here to here will be x. And then since that's x and we know here's our x, this value right here is not an x, it's a k. So we can say that x really in this case is k. So in this 2x here, since we're in terms of k, we can write it as a 2k. So if this one is 2k, then this side is 2k. And if this side is also 2k over here on the right, then we know that this length from here to here is k, which means that this whole side down here is also 2k. So that means we got AC is 2k, which would be this side right here. We've got AB is 2K, which would be this side right here. And then we've got a K and a K, so this side is 2K. So I can add all those up. So we can write an equation for the perimeter. So I know the perimeter is going to be AB plus BC plus AC, which means I'm just all the way around. And remember, we could call this side A, this side B, and this side C. And that's where all of these side lengths are coming from. Well, we know that it's 2K, 2K, 2K. Do we know the perimeter? We sure do. It is 624, and that equals 2K plus 2K plus 2K, which is 6K. Divide both sides by K, and you get K equals 104. So let's go ahead and let's finish this up. This is the last of my short videos. There's a total of 13 of the short ones. There's 12 others, plus I'll do a long one, which this was a long video here. It's 16 minutes long because it took so long on plugging in all of those. Make sure that you follow me on TikTok, Instagram, X, Facebook. Subscribe to my YouTube channel and send me any emails to askmrchew@gmail.com. Help spread the word because I want to help you in algebra, geometry, arithmetic, pre-algebra, and preparing for the SAT. I've got lots of different videos. Check them out on my YouTube station. So I will, or my YouTube channel. I will be posting next the very long, which will probably be over a half hour to 45-minute video that has all 27 together in Module 1. Thanks for watching. Hopefully this is helpful, and I'll see you in Module 2. Have a great one.